Number 18, test hypothesis null. Sigma is 2.3 versus alternative. Sigma is greater than 2.3. Random sample size 18. Obtained from a population known to be normally distributed. Okay, because the sample size is not big enough, so normally distributed. Complete parts A through D. So if the sample standard deviation is determined to be 2.1, we're going to compute the test statistic. Of course, we can use chart and everything, but we'll go ahead and use StatCrunch. So this is going to be the variance test, sample variance. So remember, we are given the standard deviation. We are asking for the variance. So the sample, S is the sample. It's going to be 2.1 squared. Okay? So you square the standard deviation to get the variance. So 2.1 squared, 4.41. So that's the sample variance, 4.41. All right, the sample size was 18. All right. Now later on down here, it tells me researcher decides the test at alpha equals 0.05 level of significance. So I'm going to go to, oh no, this is the sigma squared first, 2.3 squared. Sigma squared 2.3, square that, and get 5.29. We were testing equal versus greater than, and we can do both. I'm gonna come back. It is at the 5% level. So I'm gonna let it go ahead and do a hypothesis test. Show critical value, level of significance 0.05. Let me just make sure. Yep. Okay. So we're gonna compute. And I'm going to go back to options. I'm going to do edit, and we're going to do a confidence interval just in case we need that one as well. So we'll have both things, or I can just go back and do the other one. So here gives me the confidence interval, lower limit, upper limit. Go back to options, edit, hypothesis test, and compute. I thought it kept them both, but it does one. All right, so the first thing we want is the test statistic. So that will be chi-square statistic. So we want 3 decimal places, so that's 14.172, 14.172. All right, the critical value right here, critical chi-square, is 27.587. 27.587. So this is a right tail test, means we're looking at this scenario here. Will the researcher reject the null? Okay, so let's draw this out. So make sure we're seeing everything. So if we're dealing with this chi-square test, right tail, our test, our critical value is way over here, 27. That's giving me 0.05. Our number is way smaller, so going left to right, it gets bigger. So our test statistic came out to be like 14. So we are not in the rejection region, so we do not reject the null. So in this case, our test statistic is less than the critical value. So we do not reject HO. So D. 19. Data from a simple random sample with 25 observations was used to construct the plots given below. The normal probability plot that was constructed has a correlation coefficient of 0.97. Judge whether the t-interval could be constructed using the data in the sample. So here's the data. We got a box plot. So correlation coefficient values, 25, so 20, and we got 0.959, which this is greater, so that's good. So the normal probability plot suggests that the data comes from normal because the 970 is greater than the 959. And the box plot does not show, so when looking at this, there's no outliers, nothing way big or way smaller. So the T could be constructed. And so that's all we do there.